All right, everyone. Today we're moving on to our next section of quadratic equations. Today we'll be talking about the zero product property. We will be focused on how the zero product property helps us find our x-intercepts, and we're going to use the zero product property to help us solve quadratic equations. So specifically, it says I can solve a quadratic equation by factoring. Today we're going to start in what's called factored form. Tomorrow we'll be working on going from standard form to factored form where you guys will actually factor. So really our biggest goals for today, I can use the zero product property to solve equations, and then I can find those x-intercepts algebraically. So the zero product property, for any real numbers a and b, if a times b is equal to 0, then we know that either a is equal to 0 or b is equal to 0. So if it's 5 times 0, that's 0. If it's 0 times 5, still 0. So if the product of two numbers is 0, we know that at least one of them has to be 0. So we're going to walk through a couple of these examples here. You'll see in example 1, the first one, it says the quantity of x plus 1 times the quantity of x plus 4 is equal to 0. This is a quadratic function. If we were to distribute, we would have x squared plus 4x plus 1x plus 4. So our quadratic equation would be x squared plus 5x plus 4 equals 0, or is equal to y. Now we know this as standard form of our quadratic equation. So last unit, when we talked about factoring, we went from a trinomial and we factored to get a binomial. So we look at x plus 1 and x plus 4. 4 times 1 is 4. 1 plus 4 is 5. Today, we're not going to be starting from standard form and going to factored form. We're going to start in factored form, which is this form here at the top. But I want you guys to make that connection that if we were to distribute these two binomials, we'd end up with this quadratic trinomial where we see that x squared plus 5x plus 4. If you remember from yesterday, what makes an equation quadratic? It means the degree is 2. The biggest exponent is 2. So when we start in factored form, that gives us these two groupings. So x plus 1 is a factor, x plus 4 is a factor. Together we are multiplying. We are multiplying these two factors together. Our product is equal to 0. So that means x plus 1 is equal to 0 or x plus 4 is equal to 0. So I'm going to split those two binomials and set them equal to 0. So that means the values I pick for x, I either need to make this first quantity equal to 0 or the second quantity needs to be equal to 0 in order to get 0 as a product. Set each factor equal to 0. Solve that equation for x. So we take away 1 from both sides. We get x equals negative 1. Take away 4 from both sides. We're just solving this equation for x. We get x equals negative 4. Well, if we're working with a quadratic equation, we always kind of think about, well, the generic form, it would just be equal to y. In this case, we've set each of these equations equal to 0. Where are the points where y is equal to 0? Well, those points are on the x-axis, negative 1 and negative 4. So these represent our two x-intercepts. Now I'm going to have you go to Desmos. So you're going to go to Desmos.com and click on the graphing calculator. And then where it says start graphing, you're just going to type in x plus 1 parentheses x plus 4. You don't need to set it equal to 0 in Desmos. You just need to type in your quadratic equation. So I want everybody to go ahead to Desmos.com, type in parentheses x plus 1 times the quantity of x plus 4. So now that you've graphed that in Desmos, you should see that you have a vertex at negative 2.5, negative 2.25. And then we have a y-intercept at 0, 4. So I went ahead and I graphed this parabola, which you guys will do here. You'll plot that point at negative 2.5, negative 2.25. That is my vertex. I'm going to plot both x-intercepts. I'm going to plot my y-intercept of 0, 4, where it hits the y-axis. You'll see I've drawn my axis of symmetry through the vertex, and then I've reflected those points to the other side. We now have a parabola that faces up. I've labeled the vertex, and I have labeled the y-intercept. So our focus here today is going to be solving a quadratic equation and finding the x-intercepts. After we've found those x-intercepts, we're going to plot those points on the graph, find our vertex using Desmos, label that y-intercept, and then sketch our graph. For the next one here, we have x times x plus 5. So x is a separate factor. So we're going to set that equal to 0. And then we're going to set x plus 5 equal to 0. Now, because we have that variable x that represents a term, it's not a coefficient, it has a variable. So that counts as a factor in itself. So we set x equal to 0 automatically. If x was equal to 0, we would have 0 times 5, which would be 0. That x by itself gives us an x-intercept at x equals 0. I go ahead and subtract 5 from my second factor, and we get x equals negative 5. I can go ahead and put a point on the x-axis there then at 0 and negative 5. I would like everybody to now go to Desmos again, type in x parentheses x plus 5 in the graphing portion, and graph that parabola. All right, we have a vertex at negative 2.5, and then negative 6.25 is the y-coordinate of our vertex. So that's at negative 2.5, negative 6.25. So just a little past negative 6. I'm going to draw my axis of symmetry. That's the vertical line that splits my parabola in half. Remember, that is the equation of the vertical line. It's the same as the x-coordinate of the vertex. And then we're going to go ahead and sketch that parabola using my vertex and my two x-intercepts. So really, to break down our learning targets today, I can solve a quadratic equation using the zero product property once it's factored, and then I can algebraically find those x-intercepts and plot them with the help of Desmos as we work on finding our vertex. I'm going to do one more example with you here in 3, and then you guys will be responsible for working on 4, 5, and 6. So in example number 3 here, let me erase that mark. We have x plus 1 times a quantity of x minus 3. Remember, each group of parentheses represents one of your factors. So I have x plus 1 equals 0, then I have x minus 3 is equal to 0. We're going to solve for x. I'm going to take away a 1. We get x equals negative 1. I'm going to add 3 because I want to get rid of that negative 3, and now we have x equals positive 3. So when your quadratic equation is in factored form, we take each factor, each group in the parentheses, set it equal to 0 because we know as long as we're multiplying a number by 0, the product will always be 0. I'm going to go ahead and plot my x-intercepts at negative 1 and positive 3. I know my axis of symmetry will be at x equals positive 1 because we have a vertical line, x equals 1. I know that the x-coordinate of my vertex is going to fall on that line. Now you're going to go to Desmos, type in x plus 1, and times the quantity of x minus 3 to find your vertex. Now we found a vertex at 1, negative 3. That would be, 1, negative 4 is our vertex. We have a y-intercept at 0, negative 3. So anytime I can plot both x-intercepts and my y-intercept and the vertex, I'm always going to do that to make my graph a little more accurate. I've reflected my y-intercept to the other side of the axis of symmetry, and I can now sketch my parabola. So we're working on sketching our parabolas today using our x-intercepts, our vertex, and our axis of symmetry. So I'd like to see two things labeled. I'd like to see the vertex. I'd like to see your y-intercept if you are able to plot that. And then I'd like you to write your axis of symmetry as well for the practice. You are solving algebraically for my x-intercepts over here. Now, I would like you guys to take the time to go ahead and work on examples 4, 5, and 6. After you've worked through each example and then graphed it in Desmos, press play on this video to see the answers for example 4. Try 5 on your own, play, see the answers, and then you will try example number 6. Here's your solution for example number 4. X-intercepts at -2 and +2. Vertex and y-intercept at 0, -4. And example number 5, we have an x-intercept of 0. We also have an x-intercept of +4. You'll see those 2 points are labeled on the graph. We have our vertex at 2, -8, and our y-intercept was 0, 0. The axis of symmetry would have been represented by the equation x equals 2. Please move on to example number 6 and then check your work. In our last example, we have x-intercepts at +10 and +4. We have a vertex at 7, -9. Our y-intercept here is not going to fit on our graph. That would be all the way up at +40. So here, having our vertex and our 2 x-intercepts is good enough for our sketch. If I wanted to represent my axis of symmetry, which is great for the practice, remember that's the vertical line that goes through the vertex. It must have the same x-coordinate as the vertex. So our axis of symmetry would be x equals 7. Mr. Tucker has an assignment for you to work on in class. Please ask him with questions as you work through solving and factoring.